Hi, my name is Hw6. This is my video for the homework 6 problem 1. For the first problem, we need to find A so that the bar different density function is valid joint density function. So according to the property, we have the distribution function should be infinite. The two variables are infinite. So the distribution function should be equal to 1. So after the calculation, we get A equal to 1/4. For the second, we need to prove if x and y are uncorrelated. So according to the property, if they are uncorrelated, the mean of xy should be equal to the mean of x multiplied by the mean of y. So first, we calculate the mean of x. So the mean of x is equal to the x multiplied the density function of x dx. And for the density function of x, after we calculate is equal to 1/2. So this part is an odd function according to x. So this should be equal to 0. So similarly, the mean of y is also 0. However, the mean of xy, after we calculate this integral according to definition, we have the result is 1/9, which is not equal to 0. So x and y, they are not uncorrelated. So for third part, we need to prove if x and y, they are independent. So however, the density function of xy is not equal to the density function of x multiplied density function y, because we have this density function of x is 1/2 and this function is 1/2 also, but the density function of xy, they are not equal to 1/4, so they are not independent. So for the first part, we need to find the joint density function of x squared and y squared. So first thing, we let z equal to x squared, and its range is from 0 to 1. And w equal to y squared, and the range is also from 0 to 1. So according to the lecture notes here, we have the calculation for the g, x, and y. Gx and y equal to 4xy. So hence we have a 4 value for gxy according to z and w. So this 4 part minus plus 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 minus minus plus minus, and we put this 4 into the equation here. F(zw) equal to blah 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 here. So we get the density function of w equal to 1/4 squared zw. So otherwise, this part fcw is 0. So this is only for z and w at this range from 0 to 1. So we need to prove if they are independent. So first, according to definition, we get the result of fz equal to 1/2 squared z, and fw is 1/2 squared w, which makes that fzw equal to fw multiplied by fz. So x squared and y squared, they are independent. So here we have the question for problem 2. Problem 2, for first A, we have find A so that the above definition defined function is a valid joint density function. So similarly, according to the property, this integral should be equal to 1. However, since the range is x squared plus y squared smaller than 1, this is a circle, so we let x equal to r cosine theta, y equal to r sine theta. And theta is range from minus pi to pi, and r is from 0 to 1. R is the radius, and theta is the angle. So we change this integral to here, so we can easily get the result. We can easily get the a should be equal to 1/pi. And the second part, we need to find the stereo mean function. So for the first mean, according to the definition, it's really very easy to get. So the mean is according to definition, mean of x is equal to the integral of x multiplied by x fxy dx dy. So after we solve this equation, we have we have this. So this is equal to 0 because for this part this is odd function. Yeah, this is odd function. So this mean is equal to 0. Also for the mean of x given y is equal to the integral of minus infinity to infinity x, the density function of Rx given y. Okay, so in order to solve this part, we need to know the density function of y. So Fy is equal to 0, so this is also 0. So similarly, if we replace the smaller one to the bigger one, which variable, which it also should be 0, and due to the symmetry, this 3 is also 0, and for the xy, for the exy, which is equal to the mean of, according to the equation, which should be also 0, which is equal to the mean of x multiplied the mean of y. So x and y are uncorrelated. Yeah, so yeah, this is Hw6 problem 1 to 2.